Lab 12, Force and Acceleration Simulation with Vector Grid. And it is same Vector Grid software. We're going to play this little game to learn about vectors, magnitude, and directions. So now this is to simulate Newton's second law, and we talk about accelerations. And what causes acceleration is the force. And what is the force then? You push and pull, and with your hand. Okay, and then you will say, well, what's the force and acceleration? How are they related? So actually, force causes the acceleration, and both of them are vectors. Whenever you see vector, they will have directions and magnitude. Okay, what about the direction of acceleration? Well, it's a vector. Whichever way is speeding up, okay, acceleration may not, or may not be the same direction as the velocity. That's what makes acceleration a vector. It's different. It has its own direction. But what's the direction of acceleration related to the force that causes the acceleration? Well, that's simple. Acceleration and the force that causes the acceleration are in same direction. Once again, that's Newton's second law, says force and acceleration are proportional. Okay, and the more force you apply, the more acceleration you will have. You see, you push harder, things speed up faster, and acceleration is in the same direction of the force. Okay, in other words, where you push, where it accelerates. So, force is in the direction of acceleration. Acceleration, not velocity. It may or may not be in the velocity. So in this lab, it's actually to demonstrate acceleration direction relative to the velocity. We actually simulate three scenarios. First, we will force in line with velocity, which means simply pushing same direction. So that will make the object move faster. And the second scenario, force against velocity. And then, of course, that's the deceleration. And deceleration. And the third situation, the force is in the sideway, which means pushing outside and make it velocity change directions. So when the force is in a sideway, which means maybe perpendicular or is in an angle with velocity, then the acceleration will be in different direction as the velocity. That will make the velocity change. Once again, velocity change is caused by the force, and velocity change is the acceleration. We simulate three scenarios. First one, accelerating, getting faster and faster. So you have seen a vector grid, and you have all these vector grid. And then what do you have? You set the game to start, make the blue cannon at the corner. Sometimes it's over here, and it's a 45 degrees, sometimes over here, but most likely it's here. And then once you have this, and you need to clear the field. Usually it start out with a line of this, a line of vectors, but you need to cancel this so that to do our simulation. So feel the now once you achieve that and feel the force in the same direction as the travel the cannon, the blue ball, shoot the blue cannonball and observe how velocity changes. And these two do two trials with different magnitude of forces. All right. So for example, this way, and with a little force, and when it come up, and then the blue ball will be going faster this way. But that's 135. And you try another time, but this time the blue the cannon was here, and then you shoot out, and it's stronger force. You will see it start up faster. And take a video, and that's it. Well, you pick the game, but when you start, but there's something to do. But doing this will also help you understand the idea of the vector better. So you start a new game, easy game, and then they start off, forget this case, all these vectors. But actually, I don't want this vector. I want all the vector go that way. So therefore, I need to clear out this. So this is something you need to do in any lab, which is not directly related to the objective. So what you do, the trick is you try to see to cancel this by adding the opposite. You say, well, you have, say, this is 200 and 225 degrees, and then you will say, well, no. So then you cancel it, and then you boom, you add to it. You click this adding, and it will add to 0. Then you clear the field, then you can add whatever force you want. First project is to cancel it, but this is one of the things I want you to do in the previous lab. All right, some of you haven't handled in the previous lab yet, but that part is, So now let me try. So I'm not really good at this, but let's try this. Okay, let's see. For example, if I say, well, this angle, it looks like on B, then I will do it on C. Okay, and see if it matches, and then I know what exactly this vector is, and then it will go negative. For example, I think maybe 225. Okay, let me put 100. All right. See if I will do on C. See if it matches with that one. Uh-oh, it's too much. 255. No, definitely not. Then I will immediately do a negative, which means delete that and then come back. So then I will first try the angle. Try to match this. So how at the same time how about 200. So for the angle, well, a little bit less. So you see over here, 200 is a little bit less. Okay, that's, and then we put here, and then it's gone. Okay, let me see. 200 is too little. So how about 210? So I will try, and then boom, looks like it is 210. So, well, you don't have to be exact, but see, we are trying to, let's say 210. Still a little bit too more, that's what I think. So let me do that. And as 210. Okay, and gone. And let me do it 205. Okay, 205. Let's see. 05. See if, okay. 205. It's okay. So I think it's 205 is good enough. 205. Don't have to be exact. Just look at 205. So I know the angle is 205. Now of course I delete this. And here it's gone. So now I will. So I know the angle in B is 205 degrees. So now I will slowly add the vectors. Add the vector. Let me do add 10 at a time. Okay, and so 10. Okay, very small. You hardly see there is a little dots here. Wow. So once again, just remember how many times you click this. 20. So it'll be a little longer. 30. 40, 50, 60, 70, 80, 90, 100, 110, 120. It looks like it's 120 is about the same. Which one? What do you think? 120? Is this bigger or small? I think it is about the same. Now I don't want to do another 120, 130 or too much. Then I reduce to 120. Okay, 120. Okay, 120. So now let me do 125. So 125, no, not 25. All right, so I just try 120. So I know, so the vector on B and C, they are the same, 120. So now 120, so then I know it's 120. Then let me do 120 minus, so all gone. So now I would do it on B, 120 negative. See if I got it right. Boom. Yeah. So this is how you clear the field. So you're ready to add. Okay. Then that way you practice your vector magnitude and direction. We clear the field. Now the blue is in here. We're gonna add the vector for a small amount of force. So let me just add. So this is the 135 degree because the cannon is 135. So therefore I add on everything 135. But let me just add 100. So 100. Right, 100 at 135. 135. I add to column A. You see? That's this. Now I add to column B, add column C, D, and E. All right, so which means the cannon come out and there will be a force like the wind. Wind will exert the force on the object. It will accelerate. And put in a simple word, it just blow this thing faster. Okay, now let's do it. Let's see. Okay, let me put the shoot button. I will click the 8. So you see that's accelerating? Yeah. So that's force cause acceleration. Boom. I do it twice, and so that's done for this part. I want to do it. Start a new game. I will do the same thing, but this time with a stronger vector to see force stronger and accelerating faster. But I again need to remove that to save time. I stop the video and do it and bring it back. Again, this new start. I already try to, like the other set, I try to match this A with this 4. I figure out it's 55 degree and 80. So you see it matches. Now I would simply do negative, it began, and then I go A. So that's when it started. I will do that. So clear the field, and then now I need add the field. It looks like this is like 45 degree. The blue cannon. I'm going to shoot the blue cannon. So then we'll do some strong forces. So I'll do 100 maximum every time. So 45 on A. So that's 45. So it's same direction, the force. And then I will put, I want to be stronger. I will have another 100. Okay, actually, let me do, it's supposed to be 45 instead of 40. Okay, 100. Max, every time you should add 100. So 45. You see, 45. All right, 45, and then another 100. They're stronger, maybe very strong. I just to make so 300 at 45, and then I'll put on here B 300, C. Yeah, you can choose whatever number, but this is sort of a simulation to get an idea. So that's the force on the field, or this wind. Force causes the acceleration. So that's the force. Alright, so which means if you shoot the blue one, it came out. Let me see, almost, yeah. You can see the blue. And then the force, the same direction, it will go accelerating. It's called getting faster. So you see, shoot the blue one. Oh no, I don't shoot the red one. Shoot the blue one. You see? Well, go very fast. Actually, I can't even see. Let's do it again. The blue one, and then super fast. But if you shoot the red one, it's beginning to blow a circle. So if you shoot the red one, it's between the side. That's what next. So that one. You see the red one? Correct. Because the wind blow. What about the green one? Okay, the green one will be the opposite to the force. So that's deacceleration. You go here. See, it blow right back. The green one right back. The blue one. So now we shoot blue one, take a value. So this part. Okay, and all right. So that's it for the second part. We done one accelerating, one deaccelerating. Now one accelerating stronger. So now we come to the second part, deaccelerating and slowing down. So to save time, I want you to set this up. So and then this time I will just shoot the blue one. So this case strong. Now in this case I just use the same thing. But this time I shoot the green one. It will be a deaccelerating. I go faster, faster, and faster, right? Deaccelerating. But the acceleration is the force. Once again, acceleration is in the force direction of a force, and both are vectors, but they are the same vectors. But the velocity is another vector. But velocity come out from the green, and the acceleration is opposite, and therefore you get let's shoot the green one. So you take a picture of this one. The acceleration, the green one come out. So that's a strong one. All right, right, the green one. So now that's done. Take a video of that. I only want, so you deacceleration, in this case I only want you to choose the blue one. So make the blue against the vector. So you go in this way and make it stronger. Do 2 trials. So okay, let's do that, and let me use the blue. I want you to use blue. To save time, I just use the green, but it's symmetric. So you see what I'm trying to ask you to do. And so you do, so reduce the field to smaller, okay, and of course smaller, and C, smaller, B, and smaller, and A, smaller. So now I still shoot the green one. So this is the green one come out this way, while the force is acceleration against the velocity. So the velocity will be reduced, but this time compared to the previous time, it is in a different direction. It's weaker, but still but the accelerating is slower. Remember what the previous looked like. So this one, I shoot the green one here. You see, you go this far, okay, and the last one you go this far and bring it back. So I keep on shooting and shoot and go this one, okay, and this is deaccelerating. Look at the green ball. Take a video on this. So the green ball come out, boom, okay, and if when the field is strong, it only goes. Let me just try to make this E strong. Okay, and E stronger, you will see it will push back much quicker. You see, now if you shoot the green one, okay, I don't shoot that far. I don't go that far, but if I go that's deacceleration. If I add more force, huge force, and huge force, so that's the maximum force you can do. So if you shoot the green one, come right back. Right? Because the strong force against the velocity. The acceleration is in opposite direction of the velocity. So so there's strong one. I just want you to do 2 cases. The third one is the sideway. It's like a gravitational field. To make this field, again, you want to clear out first to make too strong. You either shoot green or blue. So the gravitational field is like everything you throw in the air. It will experience the force of the gravity going down. Okay, and of course on different planets, the gravitational force will be different for the same object. So let me just do this. Basically, this is 270 degrees down. So now let me do another one. Okay, another one. So we do new game, start a new game. So I have to clear out this. To save time, I will clear and come back. Again, I figured out this random star is 110 at 25 degrees, so that's 25 degrees, but that's 110 in magnitude. So then I just do a negative to cancel this out. See the negative. Oh, it'll be going, but onto D, and that's when it started. You have to figure out, and so I clear the field. Once I clear out field, what is set up the gravity field, and this is the acceleration in the sideway and different direction of the velocity. So that's, well, let's make it a weak gravitational field. So that's pretty easy. 270 degree. Let me try 100. So then you have 100. So straight down is 270, right? 90, 90, 90. So 270 degree. So add to A. You see that? Okay, add to B, 270. So now add to C, and add to D, add to E. So now, so that simulates the force of gravity. Everything experiences gravity in the air. So the acceleration is always downward. And on Earth, it is like the force is 9.8 meters per second squared. But this could be anything, but the direction is in general. So let's shoot the blue one. It come out, the velocity is still the same direction, but the acceleration will go this way, always downwards. So let's see. Let me shoot this blue. The acceleration always in the same direction as the gravity force. I shoot the blue one. Okay, and you go. Oh, that's red. All right, so here the blue. You see blue come out, and then wow, that looks like a projectile. So acceleration in the same, always in downwards. So it go up. So the acceleration to the sideways. So acceleration. All right. So make a picture of this. So now you shoot the blue. Shoot the green will be a similar thing. Shoot green, because the goal was pushing it down. So acceleration is in the direction of force. Acceleration is in the direction of force, not in the direction of velocity. The velocity is in the direction where the object actually goes. Okay, the velocity is when where actually object goes. Acceleration is where the force goes and where velocity changes. Once again, acceleration is where velocity changes. So the velocity actually change directions because of the acceleration. I shoot the blue one. Okay, I'm just curious if I shoot the blue one, it looks like a parabola. But if I shoot the red one, it's going to be going downward. It's like you throw something downwards because they're going, whoa, like throwing from a tall building, but it's going faster. And so drop something from high building and going boom, drop because of the gravitation of the red one. So this case, in all of these cases, the acceleration is in a different direction from velocity most of the times. Because the acceleration always go in the direction of the force. Let's see what we want to do next. So yeah, we simulate this one, and now we simulate this one, maybe stronger. See what happens. Okay, let's make it stronger. So that's easy, right? You just make it add more, stronger, and add this as long as we figure out direction, still 270. Stronger, gravity, stronger, and stronger. Okay, now if you do this, so now let's try. So take a video. So if you see when you do this, you have ask your lab partner to help you do this. It'll take 1 second. Once you do this, and let's shoot the blue one. So remember last one, it goes, whoa, go to here, right? It goes to here. But this one, this time, the acceleration much stronger. What will happen? Whoa, see? It just don't go that far because the gravity is so strong. With same speed come out, but it change direction. Acceleration makes it change directions. Once again, acceleration makes it change directions. So now, how about the green one? I shoot the green. I see it's all closer, it's stronger. Okay, that's when if you take it to Jupiter, it can throw very close, but it turns real fast. Strong acceleration, you push it sideways. Now, if you shoot the red one, it goes real fast, right? The red one. So that's it. Basically, this is the lab. Once you've simulated all 3 cases, then you are done. All right. So once again, the moral of this lab is to demonstrate the idea of Newton's second law and illustrate the idea of the forces and accelerations as well as velocities. They are all vectors. Okay, and their relation is acceleration is the change of velocity. Okay, either in the same direction, in the opposite direction, or in any other random direction relative to velocity. Definitely not always in the same direction. And the force, push or pull or or knock or something, is always in the same direction as the acceleration. Once again, the force in the same direction as acceleration, not in the same direction, not necessarily in the same direction as velocity, but in the same direction of the acceleration. That's called Newton's second law, and that's part of Newton's second law. We'll talk about that in class. All right, if you have any question, please send me a message. We're done for this lab.